Okay, today we're going to do some Archimedean spirals. One of my favourite spirals. I love the sort of like how it just winds its way out. You see it's so much roundabout everywhere. It's said to be discovered by Archimedes, but it's probably one of his disciples, Conon of Samos, they think it is, about 200 BC in ancient Greece. And we're going to look at the path of the spiral. So the maths of this is the path we're going to call E is going to be 2 pi a. So it's 2 pi a. So that's going to be the path of the whole way around on there. So each time it does a complete rotation, it will have moved on by 2 pi a. So we're doing a 4 split on here. So obviously each one of these ones, we're going to divide it by 4 onto here. So the first one on here is going to be 0.5 pi a, then pi a, which obviously is 1 pi a, but we don't count that. We've got 1.5 pi a, then we will have 2 pi a, and obviously 2.5 pi a, 3 pi a, and on and on. Let's make a start. So I'm going to make my life easier. I'm going to say pi equals 3. We know that it's 3.14, 3.1425, going on forever onto here, but we're going to use 3 just to make it a little bit easier for when we're working these out. We're just going to do a 4-point spiral. Obviously, you can do these as many points as you want, but we're just going to keep it nice and simple to start with, and I'll show a little video, separate video, just to help you if you want to do a more accurate version of this on here. So if we start off with the formula, if you remember the formula was 2 pi a. Pi is 3, and a is what we call a constant. And that means it's going to stay the same throughout this one. We're going to choose what a is. So I'm going to say a is 2. And it'll just keep it quite tight on there. If you make this bigger, your spiral gets bigger as you go along, so it goes out faster onto here. But I quite like them quite nice and tight on here. So we're starting with 2 onto here. So if you remember back, the 2 pi a is after a full turn, so we're going to go back to the first one. So I'm going to start at 0 on here. And then our next one is going to be up here, to this bit, 2 pi a. So 3.14 times 2, sorry there, and divide by 2. So it gives you 3.14. So our first one is obviously going to be 3.14. So we're going to measure 3.14. And we can't get very close into there. I've just realised I just said I'm not doing it. I'm just so used to using pi as 3.14, I've actually used it on them. So it's obviously been 3 onto this bit then. So we're going to look at the next one. The next one along will be pi a. So that'll, on this one here will be pi a. So that will be 3 times 2, which we don't need to do there because it's going to be 6 here. 6. The next one along will be 1.5 pi a. So we're doing 1.5 times 3 times 2, which equals 9 onto there. Onto there. And the final one, remember, once we're doing a full circle onto there, is going to be 2 pi a. So we'll do 2 times 2 times 3, which is going to give me 12. Obviously, you don't need your calculator if you're doing these as pi is 3, but if you want to go more accurate onto these bits there. So we're going to have a look at this spiral to start with. So it's starting to spiral out. You sort of like build your spiral around, and you can see it's starting to come out now. So the next one on here, because we know that distance here is 2 pi a, we've worked that out on here. 2 pi a equals 12, because 2 times 3 times 2 is 12. So every gap from now on is going to be 12. So our life is so much easier now, because all we have to do is we have to measure 12 out. And then from this point here, 12 out. From this point here, 12 out. From this point here, 12 out. I'm going to stop each time because then otherwise it gets confusing, and I'm going to put the spiral in. Now try and make the spiral come round. It's not as easy with a 4 point. It's much easier when you've got 8 point or 16 point spirals. Onto here. And then 12. And you start to see the Archimedean spiral is coming out. Now at this point here, if you wanted to, you can make it a little bit easier by splitting this in two, by drawing a line that way and that way, and you've turned it into an 8 point. You see I'm not measuring, these are 45 degrees, but I'm measuring this one. So every time you come to one of these intersections, it's going to be 12. You see it's keeping an even constant all the way on here now. And again, now we've got to this stage, because we're getting the larger, we can actually split it again. And obviously you can go on forever, going round and round and round onto this. If you want to make your spirals further apart, you change your constant and make that bigger, maybe a 3 or a 4, and your spirals get a little bit further apart. So if you want to do a really large one, something on a wall or something like that, then you can really sort of like really expand that out. And also you can do on these ones as well, is because you've got all these different sections, you can do sequences of colours working around. So you could do red, blue, green, yellow, red, blue, green, yellow, and you get beautiful spirals working their way around, each one shaded in carefully on there. So again, that's all these sorts of things. Just experiment and play around with it. Have a go with the maths onto here. There are more complicated maths you can do with this, but that is definitely for another time. Okay, enjoy your spirals. Red book, green book, calculator. Red book, green book, calculator. Red book,